Good morning, everyone. I know it's quite hard to bring people back from the break, but I'm glad we are here. So as Arpit mentioned, my name is Sampada Basarkar, and I lead engineering in Vodafone, primarily Vodafone Business. So today I'm going to talk about InstantX, which is Vodafone's edge innovation platform. And we'll talk about how InstantX was born, what was before InstantX, and we'll go from there. So moving on to the next slide. Okay. So I'm going to cover four things today. One, I'll talk about the Safer Transport for Europe platform, which is, we have an acronym inside Vodafone, and we call it STEP. The second thing that I'm going to talk about is InstantX, which is our open source version of our edge platform. Then I'm going to talk about our engagement with the open source community and just some closing thoughts. So let's start with STEP. What is STEP and why STEP was born, and what are we doing with STEP, and how later on I'll talk about how InstantX was born from STEP. So STEP is our Safer Transport for Europe platform, and it connects traffic participants with each other. So as you all know, Vodafone has a really big IoT business. We have close to 200 million IoT SIMs that we manage. We have a large automotive business as well. And Safer Transport for Europe platform was really built as a solution on top of that. And the idea of Safer Transport for Europe platform was really to connect vehicle to everything. So it's a V2X platform where you could connect vehicle to road participants, vehicle to other vehicle, from vehicle to vehicle, or vehicle to network, as well as vehicle to infrastructure. So that was the whole idea of V2X platform, which was STEP. Now, why Vodafone? So Vodafone, being in telecom, has a really big edge computing network. So the idea was that the STEP platform will closely integrate with our network as well as our MEC infrastructure, which we have across Europe, and we will be able to deliver low latency solutions to our customers across Europe. So that's the whole idea of STEP platform. Now, what are some of the use cases that we've built on top of STEP? So as I mentioned earlier, STEP is a V2X platform where you can connect vehicle to other users, where you can connect vehicle to vehicle, vehicle to network or infrastructure. And as a result of that, we have been actively working on several use cases. So one of the use cases is the vulnerable road user use case, where you can get, on the app, you can get notifications. The cyclists, motorbikers can get notification about the other vehicle that's getting closer to them. So vulnerable road user is one of the use cases that we have with STEP. The other use case is around smart junctions, where we have digital intersections, where we give notifications about digital intersections or other pedestrians walking on the road, or even other vehicles. The third use case that we have with STEP is the green light optimal use case. And it's really an advisory use case where we notify users when the traffic signal has turned green. And you may have seen this in the autonomous driving systems or in other ADAS systems as well, where you get a notification when the signal light has turned green. The fourth use case is around the lane closure, speed restrictions, and notifications use case, where we provide early lane closure signals, warnings to the customers and users. Or if there are any speed restrictions, we provide those speed restriction information to our users as well. And then finally, emergency vehicle warning use cases as well. So notifications of an incoming emergency vehicle, or we are able to combine multiple use cases. So the time to green light optimal use case, along with the vehicle emergency warning. So there are multiple use cases we're able to combine in the STEP platform. And we're also collaborating quite actively with a lot of public funding companies here, as well as projects to drive innovation. So we're collaborating with road infrastructure providers to apply for public funding projects and to drive innovation together. So let's talk a little bit about the ecosystem of V2X. So the main idea here is exchanging messages from the V2X participants using the STEP V2X messaging broker that we have. So these messages can be from vulnerable road users. These messages can be from other vehicles, from the infrastructure. So the idea here is through the car OEMs and the unconnected road users, we can provide this message interaction for the users that are using STEP. And these V2X messages and services are delivered at the edge. So that's the idea here. And it's a really good tee-up, to the earlier presentation that was done on the edge. And the most important thing here is we enable low latency, real-time use cases and low latency real-time data exchange. We work, as I mentioned earlier, we work very closely with the road operators, we work very closely with the transport authorities, and we're able to send and receive these V2X messages from the services that are running at the edge. And we're also able to send critical messages to the road users and roadside infrastructure providers from the traffic participants to improve the traffic flow, to manage the safety on the road. So one of the primary use cases was road safety and managing safety on the roads. And we've been working with a few like-minded infrastructure providers and network operators as well, the road network operators, to improve safety on the road. So InstantX, I just want to talk a little bit about InstantX. Once we started to see success with the STEP platform, which is our V2X platform, we decided that in order to increase collaboration, to increase the innovation in the edge area, we felt that it was important to really make this technology, this use case, open source. But we didn't want to limit ourselves with just the V2X use case. We wanted to have something where it's much easier for edge devices to communicate with each other, and that's where InstantX was born. So InstantX is a Vodafone project which was published in the LFH Foundation in 2024, last year. And this project, as I said earlier, has been open sourced. It has elements of STEP, and it's not primarily just focused on V2X, although V2X is one of the biggest use cases, but we didn't want to limit ourselves to just the V2X use case. We wanted this to be a real-time data exchange platform from the edge devices. And the focus here is ensuring secure, reliable data exchange in real time between users in certain geography, and it uses far edge and industrial edge computing as well. So let me just quickly give you information on what LFH does and how LFH Edge is paving way for unifying edge compute, especially for InstantX, and how we're positioning InstantX in LFH. So within LFH framework, InstantX is placed at the service edge provider side. And as you can see here, it acts like a link between the applications as well as the infrastructure. And this position helps InstantX manage data flow and improve connectivity at the edge. So the idea is to be in the middle where we can manage the data flow and connectivity as well at the edge. And as you can see here, we're working very closely with several edge users as well. And we also are very nicely placed between the EdgeX Foundry and several other open source edge projects as well. Now, what are some of the use cases and key capabilities and potential applications that we have with InstantX? So a couple of things that we have here are real-time data exchange. So InstantX enables the real-time exchange of data between users within the specific geographic areas. And this is really important because it requires immediate data processing, and as well as the response time, and especially where the specific areas where we are, some of the key features that we are looking at here are edge computing efficiency, low latency, and high reliability. So these are the key features where we're driving the InstantX capabilities. And the applications that we have where we are looking to deploy InstantX is not, as I said earlier, not just limited to telecom or to transportation. We want InstantX to be applied within manufacturing, so drones-to-drones communication, or healthcare as well. So these are some of the industries that we're looking to deploy InstantX in. And as I said earlier, the use cases that I've talked about with STEP, which is connected vehicles, automation, these are already there, but we also want to extend them to other industrial use cases as well. So what does InstantX do? So, so far, what we've delivered is message distribution based on geohash. So this is the feature that we've already delivered. We've also delivered features such as dashboards with processed message information. So this is already part of the InstantX. Now, we've already released this week additional features, which is message transformation, multiple protocol compatibility, message distribution with HC, as well as human-oriented interface protocol. So these are the messages these are the features that we've released this week already. And in 2025, this year and beyond, we're looking to release some more features, which is enable storage capabilities, metrics, analytics, insights, as well as machine learning. So these are all the features that we are planning to release in 2025 and beyond. So I want to just maybe take a minute and quickly talk about what we're doing with AGL, which is the automotive-grade Linux, and our collaboration with AGL. So with AGL, our idea here is to provide use cases such as data sharing, traffic control and flow safety, predictive maintenance, application and use cases, and continued development and ecosystem collaboration. So we've been working closely with AGL for the last few months now, and our idea is to have use cases around traffic control, traffic flow, predictive maintenance, as well as we want to have continued development with AGL, and we want to expand the use cases and applications for InstantX, working closely with AGL. So I just want to close by maybe talking about a few closing thoughts here. One is InstantX with AGL demonstrates the power of collaboration and innovation. And it's not only within open source. We also, as I mentioned earlier, we also have a proprietary version of our V2X platform, which is STEP. But the idea of open sourcing is to drive collaboration as well as innovation. Now, with InstantX and AGL, we enable a wide range of new applications, and that will definitely improve driving safety and experience and enhance user satisfaction. The other thing that we're doing with InstantX and AGL is to further facilitate seamless data exchange between the vehicles and other devices. And our plan is to do some trial use cases in the near future in a few cities. So our ambition is to revolutionize edge connectivity, and we look forward to community contribution and collaboration around this. Thank you.